Grouping and aggregation in Pandas is significantly faster on NVIDIA GPUs. Allow me to quickly summarize the three syntaxes of grouping and aggregation in Pandas accelerated with NVIDIA's open source data frame acceleration library, cuDF. So if we start off with a table like this, we have student on the left column and grade in the right column, and we want to group by the student, also known as the label when grouping. But then we also have the grade column. What do we do with that? That is our value column, and we need to do something with all those values. Generally, we're going to go grab all of the values, and it's usually a many-to-one relationship between the value column and the label column, but not always. And then we're going to apply a function. It's usually a univariate summary statistical function like mean, count, sum, or even standard deviation. And that function is going to be called the aggregation function. What can be confusing when trying to do grouping and aggregation in Pandas is that there are three syntaxes. I've gone ahead and labeled the parentheses, dictionary, and simple. The parentheses syntax is going to take the value column and the aggregation function and combine them to create the resultant column name. On a more complicated example here, you can see we have multiple value columns with multiple aggregation functions, and it's going to have a nice clean schema and column names like this. To evaluate the performance, I created a sample data frame with 400 million rows and ran it on my desktop with 32 CPUs and an 6000 RTX GPU. You can see here I'm getting over 500 million rows grouped and aggregated with a 17 times speed up over the CPU. For the dictionary syntax, it's kind of nice. We're going to take the grade or the value column, and then we're going to send it one-to-many aggregation functions in a key value pair. The syntax is a little more complicated. You can see it's a multi-tier syntax, but this is a benefit when having more complicated schemas. So here we can see the value column grade with more than one aggregation function applied to it, and then we have another value column with another aggregation function. Performance-wise, it's about the same, over 500 million rows grouped and aggregated using cuDF with, again, 17 times speed up performance over the CPU. And then lastly, the simple syntax is by far the cleanest and easiest to code, but the schema is a little left to be desired. The value column is going to be exactly the same in the resultant, which makes it a little confusing. You're going to have to rename it, but the performance is fantastic. We're getting almost 3.4 billion rows grouped and aggregated per second with an 81 speed up over the CPU. Don't forget to register for GTC. There will be numerous sessions on data science, data processing, every single day of the conference. I'll see you there. Cheers and happy coding.